So in our earlier lectures, we have discussed about what our wireless HART is and how wireless HART network is formed, what is the function of the uh, network manager, what is the function of the gateway, and how the communication between the devices is being really established in the wireless HART communication. Though the wireless HART network and protocol is very robust and reliable, but still there are if this network is not properly designed at the very beginning, uh, the data communication will not be very successful, particularly in the plant environment where there is lots of obstruction. In that situation, we need to follow certain basic design practices. So in this particular lecture, we will be discussing about the best practices of the wireless HART network and how that can be achieved. So first of all, the gateway placement. Where do you place the gateway? There are three places or three options basically. One is near to the control room or at the control room. So this gives you the flexibility of connecting the gateway to the process automation network very quickly, and the length of the wire required is very less in this case. So this is the easiest to integrate and shortest cable run. But the demerit of it becomes very far from all the devices. So communication reliability decreases. Then the gateway may be placed central to the plant network. In this case, uh, the network which have been planned, like initially we have planned to install like 20 devices. So wherever there is a middle point of these 20 devices, there we can place the gateway. It has the highest reliability obviously, but integration becomes typical. Cable run also increases. Another is central to process unit. So what happens that mostly these wireless networks, when it is developed as a pilot project. Later the pilot project becomes successful and people want to scale the project, right? So uh, so initially if we place our gateway in the middle of the plant network, then when the expansion of it comes, then again that gateway becomes far from all other devices. So another approach to it, if you know that there will be a expansion that is coming in, so keep it centrally located to the plant, not of the plant location, right? So that is another thing that can be done. So by keeping central to the process unit, you will keep like somewhere near to here, so which have distance, equal distance from all of the places. So this is what I mean. And also you can initially, if your plan is to like uh, if the initial plan is so let me delete it first. So suppose initially you have planned to place it, all the sensors are placed in this area, maybe the gantry area. Okay, so this is your plant network plan, whatever you have planned out of some project. So you can think of placing the gateway in the middle layer so that you have equal distance with all the devices. Right? But later on in any expansion comes, then these devices to communicate with any devices here will be very difficult, right? So depending on the situation you are into, you have to decide where to place the gateway. Now if you see the mounting of the antenna, the best performance is always achieved with antenna mounted 0.5 meter from the vertical surface, and it should be around 1.5 meter from the ground, right? And devices mounted more than 1.5 meter to avoid crosstalk. I mean, so devices should not be very close to each other, then there will be crosstalk. So it is always better to keep them apart by at least half a meter, and always align the antenna vertically. So gateway transmission range is basically plus minus 45 degree, and field device transmission range is around plus minus 30 degree. So in this picture you can see this is a gateway, and this is a, suppose this is a pressure transmitter and this is a temperature transmitter. So this is a gateway signal, right? This is a gateway signal, and there is, and this is the um, yeah, and this is the signal of the PT. So this is 45 degree and this is 30 degree. So in this case the PT can easily communicate to the gateway, but this is a TT. So TT is out of the range of the gateway, so it cannot communicate. So always keep that in mind while placing the transmitter or the field devices in the network. So the signal range, there are four basic category of the signal range. As you can see, this is a this is a petrochemical complex, and there are some places which are very dense, some places where you have line of sight, some places you don't have any line of sight. So depending on this, we can categorize it into four different groups. So this red marked portion, there you have line of sight. So here you can keep the distance between the gateway and field devices at around 225 meter. Then there are these places which are uh, less densely populated, like that this tank farm area. So there are less obstruction, so you can keep the devices 150 meter apart. Then there are places where the obstruction is medium, and there you can keep it at 75-meter distance. Then there are highly dense areas, typical plant area like cracker unit, etc. So there you need to keep it within 30 meter to have an effective and reliable communication. Then signal strength. In a plant environment, there are lots of obstruction. There may be obstruction due to the glass window, brick wall, metal frame. uh, there may be solid wood door. So everything attenuates the signals, right? And they have different percentage how much they can attenuate. So if you see this metal frame, they attenuate like 75%, right? And the concrete wall attenuates around 90 to 97%. So mostly our control rooms are the blast proof wall, and that almost obstruct all of the wireless signal into it, right? So so as a good practice, uh, the reduced signal strength, if it is like minus 75 dB, it is good, but our aim should be around minus 60 dB, right? So if there is loss more than 60 dB, we should redesign our network, right? Path stability should be around 60% for general requirement and 70% for control and high speed monitoring. And reliability, our targeting plan network is always more than 99%. So there are a couple of design best practices which, if followed, it really yields good results and provides you a high reliability of the network. So there are rules of maximum distance, where maximum 100 devices per gateway can be accommodated. Actually, maximum 255 devices can be accommodated in one gateway, but I mean, uh, as per feasibility, but maximum 100 devices could be allowed to keep keeping the reliability in mind. rule of 5. So 5 devices should be within one hop from the gateway. Rule of 3, always 3 nearing neighbors each field device should be. Then rule of percentage, place 25% device within one hop from the gateway. If more than 20% of the device has update rate less than 2 seconds, then the percentage will be 50%. Then there is rule of maximum distance, which says device with update rate of less than 2 seconds should be at maximum 2 hops from the gateway and no more than 7 hops from the gateway. Any device should be placed. So we will be discussing all these rules in more detail in the subsequent slides. So first, design rule, rule of 3. So, if you see the gateway should be surrounded by 3 devices, right? So, so that they can easily communicate with them. Now, there is another device. If you see, this device does not see 3 device, right? So the placement is okay for these 3 device but are not okay for the last device, right? If we have other devices, right, then the placement of this device is not okay. Placement of this device is okay considering this is the last device in the network, and this is also not okay. So if we add another 2 devices here, then every device has their 3 neighbors in between, right? So 3 neighbors are always there in the effective range. So this is a good network. So obviously the communication will work with fewer neighbors, but reliability will be less. Then design rule of 5. So the gateway should be surrounded by at least 5 devices, right? So this is like this, you can see. But so it can work with fewer number of devices, but in the plant environment there are lots of obstruction that may happen. So it is safer to have at least 5 devices, because at that time if any other obstruction comes, then like this case, if there is a movement of any truck, then there may be uh, 1 or 2 devices that may be missed out. So if you have a 5 devices, if 2 devices are missed out, then at least 3 devices you have. So still the communication can run reliably. Then there is design rule, rule of percentage. So obviously the design rule of 5 does not work when you have lots of field devices. At that time there is another rule that comes into picture, that is known as the rule of percentage. So what the rule of percentage says is that 25% of the wireless HART devices should be within the effective range of the gateway, and there is 10% minimum limit that is placed. But if the update rate is more than 2 seconds, then the 50% of the wireless devices should be within the effective range of the gateway. Then there is a rule of maximum distance, which says that if the update rate is less than 2 seconds, then place it within the 2 times of the effective range. This maximizes the speed of response for monitoring and control. And if this is not possible, add another gateway or move to the existing one. So these are all the different design rules that are available as the best practices of the wireless HART network. Please follow these rules to have an effective and reliable network. Thank you.